Okay, so now we have 7 data points, yeah? And now instead of approximating by a polynomial like before, a line or quadratic, now, many cases, maybe it's better to approximate by a exponential function. So exponential function is of the form some lambda times e to the mu t, So now the unknown as the lambda and the mu. So how do you find lambda and mu in terms of a least square approximation? So as before, we have to compute the residual. So now suppose you have R1 is yt1 minus y1. Okay, and now yt1 is lambda e to the mu t1 minus y1. But now the problem is, when you try to convert into a linear system, because there's an exponential here, so it's not obvious. So now what happens if we take the logarithm? So if you take the logarithm of R1, okay, then it will be logarithm of lambda e to the mu t1 minus logarithm of y1. Okay, and so, or maybe we just consider the difference between the logarithm like this. Okay, then when you take the logarithm, then the power will come down. So you have mu. So the power will come out because the logarithm. So first you have a logarithm of lambda, yeah, then plus the logarithm of e to the mu t1, so just mu t1, okay, then minus logarithm of y1, okay, and now you will minimize this residual. So you minimize this residual. So this one is not the same residual at before, but still when you minimize this, you minimize the original residual, okay. And then similarly you can have up to R7 theta is logarithm of lambda plus mu t7 minus logarithm of y7. And now you can see that you can rewrite this part as an equation in terms of a column vectors of residual. And now what is the matrix? So now the matrix will be, so 1, T1 up to 1, so this one is T7. And the unknown is, here you have logarithm of mu. And this one gives you mu, logarithm of lambda, and this one is mu. And then the data will be logarithm of y1 up to logarithm of y7. So now you can write this one as a coefficient matrix A, and this one is your unknown x minus the data. Okay, well, maybe logarithm of the data, logarithm of the vector y, and this one is residual vectors. Okay, so you have reduced the least square approximation by the exponential into this minimized residual of the coefficient matrix times the unknown minus the data point like before.